So we're now going to look at situations where we have a formula where the variable that we want to make the subject actually appears more than once. So here we've got 2x plus px is equal to q. We want to make x the subject of the formula. So what you want to be doing in these stages is to make sure that you get everything that involves the x onto one side of the equation, like we have here, because we've got the 2x and the px over on the left-hand side, nothing else involving x, everything else is on the right-hand side of the q. So we want to aim to get to this stage. We then want to be able to factorise that left-hand side. So both the 2x and the px have x as a factor, so I can factor it out and have 2 plus p lots of x is equal to q. So 2 lots of x plus p lots of x, that's what gets us there. So we now have it factorised. Once you have it factorised, you can then divide both sides by that 2 plus p. So x is going to be q over 2 plus p. Okay, so that's what you want to be able to get to. Now, it may well be that we have a scenario where we need to do a little bit of rearrangement first to get to that step. So let's say, for example, that we have that p is equal to x plus 1 over x plus q. And we want to make x the subject. So before we can do anything, we need to get x on just one side of the equation. And you might be going, well, it already is. We've got x plus 1 over x plus q. So we've already got x just on one side. However, we have an x in the denominator, right, of a fraction, which we don't want to have. So before you can do anything, you want to get x, the variable that you want to make the subject, out of the denominator. So what we're going to do is we're going to multiply both sides by x plus q. So that's going to move it onto that left-hand side. We're going to get p lots of x plus q is equal to x plus 1. Okay, so now we have a situation where x is on both sides of the equation. Now, you might be going, well, has that made it worse? No, it hasn't made it worse at all. We've got the x out of the denominator, but now we can get all of the x's that aren't in denominators onto one side of the equation. The first thing I would do is I would multiply that bracket out. Okay, you could divide both sides by the p, but it won't make your life any easier. So I'm going to multiply the bracket out instead. px plus pq is equal to x plus 1. Now I'm going to make sure all of my x's go on one side of the equation and everything else on the other. So I've got a bit of a choice here. I could subtract px from both sides and subtract 1 from both sides, or I could subtract x from both sides and pq from both sides. Whichever way you do it, it won't matter. I'm going to subtract the x from both sides, so px take away x, and I'm going to subtract pq from both sides, so 1 take away pq. Right, let's go up here. And now, once you're at this stage, you are at the stage that we were at for the previous example. Okay, we have two terms involving x on one side of the equation, other stuff not involving x on the right-hand side, and you can now factorise that left-hand side. So we're returning exactly to that process that we did in that first example. So factorise that left-hand side, because both terms have an x involved, and we'll have p take away 1 times x is equal to 1 take away pq. So I factored out the x there, and I arrived with that. Now I can divide both sides by the p minus 1. So x is equal to 1 take away pq over p minus 1. Now, that's me done, okay? But just so you know, if you had instead have subtracted px from both sides and subtracted 1 from both sides at this stage to get all the x's on one side, you would have ended up with PQ minus 1 over 1 minus P. Okay, these two are equivalent because all I've done to get from here to here is I've multiplied top and bottom by minus 1. Okay, so 1 times minus 1 is minus 1, minus PQ times minus 1 is the PQ, P times minus 1 is minus P, minus 1 times minus 1 is 1. So these two are equivalent. So whichever way you did it, you would have still gotten to the correct answer.